One of the greatest mysteries in modern space exploration is that we still don't know what truly lies at the core of a black hole. But what if the answer is surprisingly simple? Some scientists strongly believe that what's inside is us. According to this fascinating theory, not only is it possible, but it's highly likely that our own universe was born inside one of these colossal cosmic beasts. Amazingly, a recent observation from the James Webb Space Telescope seems to support this idea. But how could that be? After all, black holes are infamous for their destructive power, consuming everything in their path. Or do they? The truth may not be so straightforward. Stick around to the end, because you might just discover that you're already living inside a black hole. The universe is a master of extremes. It's home to places so intense, so chaotic, that they defy our understanding. Some cosmic objects devour anything that ventures too close, offering no chance of escape and rewriting the very laws of reality as we know them. These are black holes. But not all black holes are created equal. At the smaller end of the cosmic spectrum, we find stellar black holes. These black holes form when massive stars reach the end of their lives. Specifically, after exhausting their nuclear fuel, the star's core collapses under its own gravity, while the outer layers are blown off in a dramatic supernova explosion. This collapse results in a stellar black hole, typically weighing between 3 and 10 times the mass of our Sun. But things become even more astonishing when we look at supermassive black holes. As the name implies, these giants dwarf their stellar counterparts, possessing masses that range from millions to billions of times that of the Sun. Their influence is equally vast. Scientists are now confident that nearly every galaxy, ours included, harbors a supermassive black hole at its core. At the center of the Milky Way lies Sagittarius A*, a behemoth estimated to weigh around 4.3 million solar masses. Despite these insights, the exact origins of supermassive black holes remain a mystery. Researchers theorize that they may have formed either through the gradual merging and growth of smaller black holes or from the direct collapse of enormous gas clouds in the early universe. One thing is clear, though, their presence profoundly affects their cosmic neighborhoods. Far from being passive, these giants shape and influence their surroundings in powerful ways. Supermassive black holes play a crucial role in shaping entire galaxies and powering quasars, some of the brightest phenomena in the universe. Their event horizons can span millions of kilometers, comparable to the scale of planetary orbits. But more than anything, black holes are infamous for their ability to relentlessly consume anything that crosses their event horizon. True cosmic engines of destruction. This terrifying power stems from their extreme density. For perspective, if a black hole had the same mass as Earth, it would be compressed into a sphere just 9 millimeters across. This extreme compactness creates an immense gravitational pull near the event horizon, so strong that nothing can escape from it. Not matter, not radiation, not even information. And certainly not light. That's why the black hole itself is completely invisible. What we can detect, however, are the violent forces and interactions occurring around it. And thanks to modern technology, we can now observe them. In 2019, astronomers captured the first-ever image of a black hole using the Event Horizon Telescope. This black hole resides in the heart of the Messier 87 galaxy, about 55 million light-years from Earth, and has a mass of 6.5 billion suns. A few years ago, we even managed to capture an image of our very own black hole. But how is that even possible? And how can supermassive black holes exist at the centers of galaxies without tearing everything apart? While it's true that these cosmic giants can devour entire planets, stars, and enormous clouds of gas, such destruction only occurs when objects get dangerously close, right up to the event horizon, the edge of no return. Surprisingly, despite their terrifying power, black holes behave like any other massive object in space. That means other celestial bodies can orbit them stably, without being pulled in, unless they stray too close. But what happens when something finally crosses that invisible boundary and is swallowed by the black hole? What lies within the heart of this gravitational monster? While we've gained a solid understanding of what happens just outside a black hole's event horizon, the inside remains a realm where the known laws of physics collapse. Even though the formation of supermassive black holes is still a mystery, theories give us a glimpse into the strange and extreme nature of what might be lurking within these cosmic enigmas, where reality, as we know it, is completely turned on its head. According to expert calculations, the very fabric of spacetime might be twisted, chaotic, or altered in other exotic ways. At the heart of black holes, scientists believe a phenomenon known as a singularity exists, a point where density becomes infinite, gravity reaches unimaginable strength, and spacetime curves beyond comprehension. This, however, presents a serious problem. Singularities break the known laws of physics. Einstein's general theory of relativity, in particular, fails to provide any meaningful predictions under such extreme conditions. Because of this, many researchers question the concept of an infinitely dense point at a black hole's core, recognizing it as a deeply problematic starting point. Still, one thing remains certain: any astronaut falling into a black hole would be subject to an extreme process known as spaghettification. And yes, that is the official scientific term. It refers to the immense tidal forces that would stretch and deform the astronaut's body so severely that it would resemble a strand of spaghetti. This fate isn't exclusive to humans. Every object, regardless of its structure, would be torn apart in the same way. That's why sending an unmanned probe into a black hole's interior to study it firsthand is currently impossible. With no way to see beyond the event horizon, scientists are left to explore theoretical possibilities. One such theory suggests that black holes and white holes could be connected by a wormhole. In this hypothetical scenario, the matter consumed by a black hole would be expelled by a white hole in a different region of the universe, or perhaps even in an entirely separate cosmos. This concept applies both spatially and temporally, even extending into the past. As you might expect, white holes are considered the theoretical opposites of black holes. These hypothetical structures continuously expel matter, yet it's impossible for anything to enter them from the outside due to their event horizon. However, there's a significant caveat. While white holes are legitimate solutions to Einstein's equations of general relativity, there's no empirical evidence proving they actually exist. Interestingly, some theoretical physicists, like Nikodem Poplawski, offer a different perspective on what lies within black holes. According to them, it might be us. Where traditional Big Bang theory hits a wall, a new idea emerges. Within a black hole, a cosmic seed may be growing. Once the matter being pulled in reaches a point where it can no longer be compressed, the core ruptures, potentially giving rise to an entirely new universe. In this sense, a black hole might serve as a gateway or transitional phase between two separate universes. If someone could somehow survive a journey through the immense gravitational forces within, they might emerge in an entirely different realm. Admittedly, this idea may sound far-fetched. Yet, it's precisely for that reason that a recent discovery by the James Webb Space Telescope is so astonishing. It actually lends some support to this theory. So, what exactly did Webb uncover? A research team led by Laura Shamir at Kansas State University studied over 260 early galaxies in the region known as Jade's Field, previously observed by Webb. And within that data, the scientists noticed something truly unexpected. Most of the celestial objects we observe appear to rotate in the same direction. Specifically, about 2/3 of galaxies spin clockwise, while only 1/3 rotate counterclockwise. But what does this pattern tell us, and how could it suggest that we're inside a black hole? The answer lies in probability. In a truly random universe, we'd expect galaxy rotation to be evenly split between both directions. However, this imbalance aligns with the theory proposed by Poplawski, who suggests that our universe may have originated inside a rotating black hole. This concept is supported by Schwarzschild cosmology, which proposes that our entire cosmos exists within a black hole situated in a larger, parent universe. In this framework, each black hole acts as a gateway to a new, baby universe. The spin of the parent black hole would carry over into the new universe, influencing the dominant direction of galaxy rotation we now observe.